Hey folks, since till now we have performed basic featureization, along with that we have also performed some advanced featureization, some couple of data analysis. So in this session our main challenge is all about, first and foremost we have to perform something known as multivariate analysis. Again, we will just touch upon what exactly this multivariate analysis stands for. But first and foremost, let's try to read the data on which we have to perform this multivariate analysis. So first and foremost, let's try to rename the notebook that we have. Suppose notebook name is all about 6 advanced underscore data analysis, or advanced underscore let's EDA, which all about exploratory data analysis. Cool. Let me press enter. Let me rename that. Let's try to import all the necessary modules that I really need. First and foremost, I have to import something known as pandas. I'm going to create its alias as PD. Then I can think of my numpy if I have to do some numerical computations on data. Again, if you need some basic visualizations, you can always think for your Seaborn, of course for your interactive visualizations. In case you need basic, you can always go ahead with your matplotlib. Cool. Along with that, let's go inside our Python plot and let's create its alias. Let's say PLT. Let me execute. Now what we need to do is we need to read the data first and foremost. Now you will figure out this is the data set that we have and this is the path. Let me just copy this entire path and let me just paste this path over here. And our file name is all about nlp underscore features underscore train.csv. Cool. Let me append r. That's all about the r. That's all about raw string that helps Python just to read file very efficiently. So whatever it will return us, which is all about data frame object, let me store that object, let's say in data. Let me execute this line of code. And if I'm going to say, let's say data.head, cool. It will return an error which is all about file not found error. Let me check. Oh, my bad. It is nlp underscore. Cool. Let me execute this line of code. And if again I am going to execute it, now you will see this is the data that you have. Now on top of this data, you have to perform something known as multivariate analysis. So the moment I say, let's say data.columns, which is all about the property of the data frame. Again, columns is just a property of the data frame that returns all the column names in a list data structure. The moment I will execute, these are all the column names that I have. Now let's try to understand what this multivariate analysis actually stands for. Let's try to touch upon that. Again, multi basically means multiple. Multi basically means multiple. It means at a time you have to consider multiple features. So again, in this data, let me show that. Now you will see you have all these features over here. So let's try to pick up some feature. Let's say as word common, word total, word share. Let's say these are 3 features. So I can denote it as, let's say F1, F2, F3. Cool. Now if I have to perform the multivariate analysis, then I can say as, hey, F1, F2, F3. Similarly, F1, F2, F3. In general, this is a metric. Now I can say, hey, what is the relationship between this F1 and F1? Again, you can think for either your histogram or something known as distribution, because relationship between F1 is nothing but a univariate analysis. Again, analysis is typically of 2 types. The first is my univariate, the second is my bivariate, the third one is nothing but our multivariate. It is nothing but our multivariate. Bi basically means we have to consider 2 features at a time. Let's say F1 and F2. Let's say F1 and F2. Univariate means I have to just consider a feature F1 and let's say I have to understand some more trends about this F1. That's what actually univariate analysis stands for. Similarly, multivariate analysis is all about I have to pick up more than 2 features at a time. That's what multivariate analysis says. Similarly, between F1 and F2, hey, can you come up with some type of conclusions? Again, as F1 and F2, both are numerical in nature. They both are numerical in nature. Hence, we can think of something known as a scatter plot. Similarly, as F1 and F3 both are numerical in nature, we can think of a scatter plot. So it means, let's say touch upon F2 and F2. As F2 make no sense, hence histogram plays a vital role. Similarly, F3 versus F3, it's all about histogram. It means diagonally, it's all about the histogram, and rest of all the cells, it's all about our scatter plot or any other measure plot. So first and foremost, let's try to pick up some feature. Let's try to pick up all the string matching features, which is all about first ratio, first partial ratio, token sort ratio, token sat ratio, these 4 features. Let's try to touch upon all those 4 features and let's try to perform the multivariate analysis. Later on, we can also think of these CWC main, CWC max, and tons of features we have. Let's try to pick up all the set of features in the next term. Let's try to do all these things. So first and foremost, I will say, hey, let's try to create a copy of the data frame. I will say data is all about nothing but, df is all about nothing but a copy of the data. Let me execute. And if I will say df.columns, you will end up getting the same features that you have. Now, from this, let's try to consider some feature which is all about fuzz ratio, fuzz partial, token set, and token sort. Cool. Let me pass all those features over here. Let me execute. Now, these are all the 4 features you have. Along with that, let's try to pick up one more feature, which is of course my target feature, which is all about our is duplicate. Let me assign this as well, because of course, considering this feature, we can understand our data more. Let's try to execute this line of code. Cool. So this is the data. This is the entire data on which you have to perform the multivariate analysis. So let's try to store this, or let's try to rename the data frame object name. I will say MLT underscore, let's say MLT underscore analysis. Whatever name you want to assign, it's all up to you. And if you want to print, you can just print it. You can just press tab, and this is exactly that. Cool. Let me execute. This is the data frame on which you have to perform something known as your multivariate analysis. So just to perform this multivariate analysis, you can think for a very handy function, which is all about our pair plot. Let me press shift plus tab over there. You will see you have to pass some data. Your hue parameter makes a lot of sense because as it is a classification problem, similarly we have tons of parameter. Again, we have one more important parameter which is all about our variables. So let's try to consider all these set of parameter. So I will say data is nothing but MLT underscore analysis. Considering what feature, let me first pass all the values, or let me first pass all the features in my variables. I will say considering 4 features. Hey, can you create your pair plot? Or hey, can you perform something known as multivariate analysis? Similarly, considering this is duplicate feature, can you split your histogram or can you split your scatter plot? So I have to just pass this is duplicate feature in this hue parameter. Cool. The moment I will execute this line of code, now it will return us such amazing pair plot. Now you can understand what actually this hue is doing. As in this is duplicate feature, as it is a binary feature, it means it has values as 0 as 1. So this blue data point typically points to where my questions are not similar. This orange one typically says where my questions are similar. So let's say this is my feature 1. Let's say this is my feature 2. So we can understand the scatter plot between a feature 1 and feature 2, where questions are similar, are typically denoted by our orange data point. That's the power of your hue parameter. That's what hue actually does. So let's try to understand this entire visualization. You can see your diagonal is nothing but a distribution or the histogram that you have. Let's try to pick up this and understand more about this. It is all about nothing but token sat ratio versus fuzz ratio. It is all about nothing but token sat ratio versus fuzz ratio. It is typically a scatter plot between both the features that we have. And orange data points is all about we have a distribution where my questions are similar. Blue is all about we have distribution where my questions are not similar. Now in this scatter plot, you will figure out there is slight overlapping, or there is very less separability over here between blue points and our orange point. It means this feature matters a lot. It means both the features matters a lot, as we have very slight overlapping. Of course, it means we can set some threshold. Similarly, we can perform this multivariate analysis. Of course, for all these features, let's say CWC main, CWC max, along with let's say CSC main and CSC max. Let's try to perform this multivariate analysis by picking these 4 features. Let's try to perform that. So the moment I say df of all the features, let me execute. So these are all the features that we have. And along with that, let's try to consider this feature as well, because this is one of the most important feature, which is all about our target feature. Let me consider this one. Now you will see this is my data. So on top of this, I will say sns.pairplot. sns.pairplot, and I will say this is all about our data. Cool. And our hue parameter is all about nothing but this value. I will say it is cool. It is all about nothing but this. And in this variables, it means what are features that you have to consider for your multivariate analysis. I will say, hey, these are all the features that I have to pick for my multivariate analysis. Cool. The moment I will execute this line of code, unfortunately it says you have some syntax error, because here we have a closing parenthesis. Cool. Let me execute this line of code again. Now this is actually the pair plot of all the 4 features. This is nothing but our distribution, which is all about our diagonal, because in diagonal we will end up getting, of course, our distribution. Along with the rest of the plot is all about either we will get a scatter plot. Again, if both features are basically numerical in nature, we will end up getting our scatter plot. So from this you will see, let's try to pick up this, let's say CSC max versus that is CSC min. That is CSC min. Now you will figure out in most of the cases, as soon as it starts increasing, our CSC max also gets increasing. So that's how exactly you can inference from pair plot that you are actually getting. So for those of you who have any issues while interpreting this pair plot, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.